Hi, this everyone. This is before we dive into the details of the APIs and the SDKs, just want to give you everyone a quick introduction of Brevis as a whole. So Brevis is a smart off-chain verifiable computing platform. What do I mean by that is that it is fundamentally a scaling solution. So basically, we have a very limited computation capability on blockchain. I'll tell you like some examples. You can actually use Brevis to offload these computation to an off-chain environment. In that off-chain environment, you can run that computation, but not only just the computation itself, but also generate a ZK proof of that computation result. And you can then submit both the proof and the computation result back to the blockchain, where you can actually simply and cheaply verify the computation result. Most of the computation happens, but instead it becomes a glue point of verifiable computation resources. What this means is that you can actually expand and scale blockchain computation to an infinite level, because in fact you can actually itself is a single-threaded computer that can only run one application at a time. There's no way to parallel processing this, and we built something called a ZK Coprocessor as our first flagship product. So ZK Coprocessor allows your smart contract to have access to historical on-chain data, such as event, transactions, and built using Brevis. One good example is intelligent DeFi, where you can dynamically change the protocol parameters of DeFi projects. For example, you can actually run a trading volume-based fee discount by allowing user to prove on incubator programs with Uniswap Foundation and Ethereum to kind of demonstrate this. You can just search online and see some of the examples building with this. And you can also do consumer-facing applications. For example, we partner with Euro, which is a rising star in the stable token space, and we power their token launch program. So instead of one-off airdrop, now you can allow user to continuously generate proof of their interaction with the protocol and convert that into a quantitative matrix where they can use type of a one-off airdrop thing. So this allows you to actually merge and align user incentives with your protocol growth by having this continuous evergreen program of token drops. There are many other things you can do with Brevis, like pre-confirmation. You can essentially prove to the blockchain whether a certain block producer have included your transaction or not in the past, and you can do slashing and rewarding based on that. But using Brevis, SDK is quite simple. You specify what kind of data you want to read, what is the computation logic you want to run, and finally you have your entire computation logic integrated in the smart cloud. A very specific example of how you can build with Brevis using a Uniswap V4 hook example, but you can generalize that to other applications as well. So, Michael.
All right. Thanks everyone for going to do summarize the trading volume of a specific user on Uniswap, and I'm going to focus less on the Uniswap V4 hook in this talk, but more on the Brevis side of things. So first of all, let's look at how a Brevis app workflow looks like. So as you can see, we have multiple components, and we have the app service, the Brevis service, and the contracts associated with the app and Brevis. So the first step is pretty standard. You just use any sort of indexer, or you can just build your own to get the blockchain data, like the historical blockchain data from on-chain. So basically, use the graph, or use your own Ethereum RPC node to query the Ethereum blockchain, and then you feed all those data to the app service, which in the rectangular blue box that you built, and all those data gets fed into the app circuit, which is also one of the components you guys will build. And then once you have all those data and processed by the circuit, essentially you generate a your part of the proof, and then you send all those, and then Brevis is gonna combine the two to generate a the final ZK proof to be verified on the Brevis contract for the any sort of like post-processing logic. For example, like in the Uniswap case, like as soon as you get a sum of all the trading volume for the user in the past 30 days, you can like assign the user a VIP status based on their trading volume. And with Uniswap V4 hook, you can like lower the transaction fee or lower the swap fee for that particular user, which is quite useful. So this is essentially a simplified version of what I just talked about. And in this case, like we provide a TypeScript SDK or a Golang SDK, whichever you prefer. And you implement the approver service, which we have a template for, and you don't have to like write any code essentially. And you just submit your proof, which like you guys will implement the app circuit, which we also have very extensive examples. Okay, so I think this is based on our TypeScript SDK. We also provide a Golang SDK, as I said, and you can pick connection to the app approver, which was the top like blue box, and we have a template for, and you don't have to actually worry about implementing that. So like once you establish a connection, you like instantiate a new proof request, and you're gonna fill in all the data. So in this case, we're looking at Uniswap swap events, right? So, and for us, we only care about it being a Uniswap. I think this is from a USDC to Ethereum, I believe. And in this case, like it's a little bit technical, but you can see that you provide a transaction hash, a swap event, and one of them is from the actual USDC transfer event. And the data we care about is amount 0, which is, I believe, the USDC amount, and also the recipient, so that we can verify this is the Uniswap, because they have the way their like router contract set up. I think either sender, I think actually recipient is supposed to be the Uniswap router. And with all those, we start writing the circuit. So that was the providing the data part. And this is done, if you're using TypeScript, this is going to be done in TypeScript. The actual circuit, we still have to use Golang, and it's not too intimidating. It's like pretty simple logic is gonna go, and you have the allocate, and in this case, you don't need any storage or any transactions. You just need the receipts, and you can like specify a max number of receipts. I'm not gonna go into too much detail, like how you're gonna use our SDK to like execute the logic. So like, how many of you guys know like MapReduce, basic functions to calculate minimums or like calculate sums for like the common, I guess, statistics use cases? But you can also use the for loops if you choose to, if that makes things easier as well. So in this case, we first do a map over all the receipts and extract the block number, users volume in the past month, right? So we kind of need the minimum block number and also verify that it's like from the past month. And forward, and very simple to implement. And once we have the computation done, we need to output the results so that the on-chain contract can make use of it to say like assign VIP status or like give out reward or whatever volume. And we also need the minimum block number for the on-chain verification. And we also need to output the actual user address to make sure it is for that particular user. And this is the on-chain contract part of the Brevis application. Like you require VK hash equals VK hash. This is more like a technical detail, but you can just copy it. The idea is that every Brevis circuit is going to that this is the correct circuit, because otherwise you can like have some other logic which doesn't match the actual circuit, and that will be I'll present in the next slide. Yeah, in this case, like we don't actually do anything with the output. We just emit a trading volume and test it. But in reality, you can just do whatever. Like you can attach like put all that in a Uniswap V4 hook, so you can like lower the trading fee for the user. And this is the actual decode logic, which it's a little bit intimidating, but it's actually quite simple if you just read through it. You basically match whatever the circuit has. Like in the comment section, you see all those API dot. So you're essentially just extracting different bits or like bytes from the output, and you like return that. And here are a few links that can help you get started. We have a pretty extensive documentation and examples. So just go to docs.brevis.network or check out either one of the two SDKs, whichever language you prefer. And
okay, question one. As I see, this is something like a CK as a service, but you have hidden transactions or hidden data that people shouldn't be able to see.
yeah, that's a good question. So yeah, as you said, so in this particular use case, right, there isn't too much privacy, I should say, but well, like whatever we output is like whatever we care about on chain, right? So in this case, you don't actually have to like publish the all the individual swaps on chain. You can kind of like obfuscate the actual like swap events, and you can still only output these attested like volume as well as the user address. Okay, but they don't have to be public. I guess maybe that's what you're asking. So yeah, there is some privacy nature to it, but you can make it more private by options. Okay, I think if not, we can just check out those links and start hacking. And if you have any questions, just come by our booth and we'll be happy to answer.